Okay, 1 second. Okay, starting at rest, a mass m in kilograms slides down some distance x in meters on an inclined plane of theta. The coefficient of friction is u. Determine the work done by the force of gravity. So what is work, right? Work is essentially just some constant force that acts on an object and it moves at some distance, right? And that force can't be perpendicular to the displacement. So work is some force with cosine theta times change x. What do I mean by the force can't be perpendicular to the displacement? Well, if you see that cosine theta is 90, right? Perpendicular, 90 degrees, right? And cosine theta is 0, right? So this renders this entire equation 0. That's all I mean. Okay. So let's draw a free body diagram, right? So we have an inclined plane. Alright, let's just do it like this. I feel like that's a little too high. An inclined plane. Let's call this mass m, right? Mass m in kilograms. Right, work is force times cosine theta times change in distance up. So what's the force, right? Well, the total force of gravity is essentially right straight downwards. Total force of gravity is just mg, so you have F equals mg, right? So what's cosine theta? This is theta. Well, you might be tempted to just say, well, don't you just plug in cosine theta into this? And that wouldn't exactly be true because this angle is also the same as okay, so here, let me draw another diagram, right? I'm going to take this value right here, and I'm just going to move it down here, right? I'm going to take this and push it up to here, just like that, right? And I'm going to draw this entire bottom thing right here, down here. This is theta, this is mg, right? This is the force associated with this. This is a right angle, and we're only looking for the value right here. We're looking for theta in this area. So if you know this is 90 degrees, you'll know that this angle right here is 90 minus theta. Okay? So the work done by the force of gravity is just mg, right, times cosine theta, cosine 90 minus theta, times change in distance x. And this is how you would solve for the force of gravity. Okay. So what about um, friction? Right? How would you find what friction is? The work done by force of friction. Well, let's currently write out some formulas, right? We know that the total force of friction is just the coefficient of u, right, of the kinetic coefficient of u. I'm just going to write a subscript k here times the normal force, right? So looking again at the free body diagram, we know that the normal force is perpendicular to the inclined plane. So this is perpendicular to the inclined plane, this is m. And we also know that because this box isn't falling straight through the inclined plane, we know that there's going to be some force counteracting this normal force, making it 0, right? So the normal force is actually just 0. But why is it 0? So if we look down here, we'll see that, well, I'm just going to draw some imaginary lines, hope this visualizes a little better. So we know that the total force is just n, right, plus, well, minus, because this is the positive direction and this is the negative direction, minus f cosine, well, minus mg cosine theta. Right, if we take this value, we can sort of see that this is the same as this angle. So we know n is equal to mg cosine theta, right? So we just plug this into here, right? We know that the force of friction is just some value of u times mg cosine theta. But we want the work done, so work is just, right, the total force, which is this, right? U k mg cosine theta times, well, okay, so times cosine theta. But what is cosine theta, right? We're looking at the force done by friction. You can see that. How the fuck do I explain this? Okay, so you can see that the force is directed opposite to the displacement, right? So here, so even though this is the force of friction, right? The displacement is actually moving in this direction. So we know that the angle between these two, right? So we know that the force of friction and change in distance, right? This angle right here is 180 degrees. So we know that this is cosine theta, which is just 180 degrees. 180 degrees times change in distance, which is just change in distance. So this is the work done by the force of friction. And how do we find what the normal force is? The work done by the normal force. Well, that's actually pretty easy. Right? If we look at this, you can see that here. I'll just draw a picture, right? So we know that the normal force is going straight up of the inclined plane, and we know that the displacement is going this way. Changing x. Remember how I said earlier that if this is a 90-degree angle, no work is done, so work is 0, right? Because cosine theta of 90 degrees, cosine of 90 degrees is 0. So work done is just 0. And that's how you solve for this problem.